What up everyone? This is LeetCode 104, maximum depth of a binary tree. In this challenge, we are given the root of a binary tree and we are to return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So real quick, just a little visual so you can see what they're looking for. Essentially, let's say we have a set of nodes. We are trying to find the maximum depth of our nodes from the root, right? And so in this case, we'd be returning this depth, right? So in terms of code, this is pretty short actually. We have some pretty handy functions that that do this for us. But very quick, we'll return our base case. So if we have an empty tree, then we have we'll just return 0, right? So in this case, if root equals null, then we want to return 0. Cool. Now we'll do we'll quickly recursively calculate our depths, right? So in this case, we'll declare an integer which will be called left depth, which will equal the maximum depth of our root.left, right? And then we'll also look to do the same, except we'll change our left to be right. And then, so very quickly, I'll just explain what this does exactly. But essentially, this will calculate our maximum depth for the left side of our root and then the right side of our root. Essentially what we've passed in from our definition here, right? And so this will calculate, this will essentially calculate a mathmax function for the deepest that left side or right side can go. So yeah, so, and then all we have to do after it calculates our, the integers for our left depth and our right depth, all we need to do is just compare them using said mathmax function, which will do left depth and right depth. And what we want to do, because we're on the current node, we'll just add 1, right? Max depth itself will probably do this as well, or will do this as well. So if we just submit that and we check our result, there we go, fast result. Okay, terrible memory, but doesn't matter. So yeah, so this hopefully was a very simple, easy solution. I'll very quickly, just in case we don't understand what's going on in this section, what I'll do is go back to our little drawing board, and what I'll do is just explain the how this is working, right? How our code is working, right? So let's say I'll just draw very quickly our an example, right, with some numbers, because that way we can understand. So this will be 15 and we'll call this 7. Cool. So these are our nodes, right? And obviously this is our left tree and this is our right tree. So what we want to do, so we'll start at our root node 3, and what we'll do is we'll calculate the left subtree's depth, right? So this is what the function for int left depth is doing, right? So this will essentially equal 9. So this is our max depth, and our root left will equal null, right? Because there's nothing further beyond here, right? So this is the end of our depth for our left. And so in this, what it will do, it'll do a mathmax function, right? Which will take in our depth of 0, and it'll compare it to our previous, and it will add the 1 for being the current node, right? So the one node that we've traveled here. And so this will then produce our left to equal 1, right? And so then what we'll end up doing for the right side is exactly the same. So it'll mathmax this, mathmax our left and right to see if it can keep on going. It finds out that both of them are null, so it's exactly the same. So we end up with 1, or so our left side is 1, or our right side is 1, and therefore it's kind of produced the same. Sorry, I should explain as well. This comparison is any nodes that it travels from here out, right? So it's going to try and compare this left side and this right side, and it finds that both of them are 0, so we'll add just the current node, and this will produce this result. And so this will do the same. This will compare the left and right side, so we'll end up with a mathmax function. We'll compare 1 and 1 plus 1, so I'll just add this here, and this will then produce us a depth of 2, right? So our right depth is 2. And therefore, when we compare them in the end in our mathmax function, which will compare left and right plus 1 because of our starting node, left and right plus 1, or rather left or right, sorry. This will produce us our maximum depth. Anyway, I'm not sure if this little extra bit at the end was helpful, but I hope it was. Hopefully you have a better understanding of how this works. But anyway, let me know in the comments if it didn't help, or if this wasn't a helpful video, or if you're still confused or anything like that. And or otherwise, please like and subscribe, and I'll catch you in the next one. Peace.